Reminder theorem from algebraic expressions. In this video, we'll look into the definition, formula, proof, and application. The statement of reminder theorem is if f of x is any polynomial of degree greater than or equal to 1 and a be any real number, then when we divide f of x with the linear polynomial x minus a, the remainder is f of a. In divisions, we know that dividend is equal to divisor into quotient plus remainder. In algebraic expressions, f of x is the dividend. In this particular case, x minus a is the divisor. So when we divide, we'll get some quotient in terms of x and remainder. This can be written as f of x is equal to x minus a into q of x plus r of x. While doing a division for algebraic expressions, the division has to be continued till a point where the remainder has got a degree less than the degree of quotient. In this case, x minus a is the divisor. For this, the degree is 1. Degree is nothing but the highest power of variable. Here x is the variable and degree of x is 1. As the remainder should have degree less than the degree of divisor, means here the degree should be less than 1, which means it would be 0. Degree 0 means it's a constant. For this particular case, when we perform the division, remainder would be a constant and it can be written as r instead of writing it as r of x. R of x means r, that is remainder in terms of x. For constant, we will not have any variable, so r of x can be written as a constant. So this remainder can be 0 or any other numerical value, but it will not have the variable x. F of a means when we substitute a value in place of x, that gives f of a. So in this entire equation, if we substitute the value of x with the equation will get modified like this. That is f of a is equal to a minus a into q of a plus r. Now this a minus a is 0, which makes the entire term to be 0. That makes f of a is equal to r, that is remainder is nothing but f of a. We'll try to understand this theorem with the help of an example. Let us take f of x is equal to x square minus x plus 1. This is the dividend and we are trying to divide that with the help of a divisor x minus 1. First, we will try to calculate the remainder using the theorem and then validate it by performing the actual division. As per the statement of the theorem, when x minus 1 is used, we have to do f of a. But what is a here? This is x minus a as per the theorem. So in place of a, we have 1. So we'll substitute 1 here. That is, we have to find f of 1. From the equation, substitute 1, that is 1 square minus 1 plus 1. So these two will get cancelled and f of 1 is equal to 1, which means the remainder after dividing the expression with x minus 1 will give a remainder equal to 1. Now let us perform the actual division and validate this. Take x square minus x plus 1 and try to divide this with x minus 1. So here take the first term, that is x square, and here the first term is x. X square upon x is nothing but x. So we'll write this as quotient. Now x into x is x square, minus 1 into x is minus x. We have to subtract this, which means the symbols will get modified. So x square minus x square gets cancelled. Minus x plus x will get cancelled. Next the term will come down, that is 1. Here the degree of 1 is 0. which is less than the degree of the divisor. So we can stop it here. Means we have got a remainder of 1 which is same as the one that we have obtained here using f of 1. And here we'll try to understand how to choose the f of a value. When the divisor is x plus a, equate this to 0 to obtain the value of x, which is nothing but minus a. So when we have this x plus a, we have to find f of minus a. Or if it is like ax plus b is the divisor, in that case, we have to substitute x with minus b by a. How are we getting this minus b by a? Just do this equation equal to 0 and try to obtain value of x. So when we take b to the other side, it is minus b is equal to ax. And now take a to the other side, minus b by a is equal to x. Now in the similar way, when the divisor is ax minus b, then in place of x, we have to write b by a. Or say we have a minus bx is the divisor. In that case, x should be substituted by a by b. Like this, whatever is the divisor, first try to equate that to 0. Say b minus ax, the next divisor is. Equate to 0, try to solve for x value. Here b is equal to ax, taking this to the other side. Now take a, that makes b by a is equal to x. So in f of x, in place of x, we have to use this value and calculate the remainder. For the same expression, we will try to find the remainder on dividing this with x plus 2. So for x plus 2, what is the value for f of a? What is the value of a? We have to consider here. X plus 2 is equal to 0, which means x is equal to minus 2. So here we have to do f of minus 2. From the original equation, if we substitute minus 2 whole square, means this equation, minus of minus 2 plus 1. Minus 2 whole square is 4. Minus of minus is plus 2 plus 1. This gives 7 as the remainder. Let us validate this using the actual division. Take the expression, divide this with x plus 2. Okay, x square divided by this x gives x. So we're writing here. Now x into x is x square. X into 2 is 2x. As we are subtracting, change the signs here. X square minus x square cancels out. Minus x minus 2x is minus 3x. Now get down the next term, that is plus 1. Here the degree of this is 1 because here we have x and the degree is 1 here, which is same as the degree of divisor. So we have to continue it further. Now minus 3x divided by x is minus 3. So we'll write it down here. And this is minus 3x. Now minus 3 into 2 is minus 6. Again subtraction, change the signs. So minus 3x plus 3x cancel out. 1 plus 6 is 7. The remainder is 7, which is same as the remainder we have got here. Now we'll try to use another expression. Let us take this expression and we have to divide with 3x minus 2. The remainder will be given as, say this is in the form of x minus a, then remainder will be given by f of a. So what is the value of a we have to use here? Equate this to 0 and solve for x. That gives x is equal to 2 by 3. So we'll do f of 2 by 3. From the original equation, 3 into 2 by 3 whole square plus 2 by 3 minus 1. So this is nothing but 3 into 2 by 3 into 2 by 3. This is the first term. Then we have plus 2 by 3 minus 1. 3 cancels out. So 2 into 2 in the numerator is 4, and in denominator we have 3 plus 2 upon 3 minus 1. Now here the LCM is 3, 4 plus 2 minus 3. That is 6 minus 3 is 3, 3 upon 3 is 1. So after division, we have to get a remainder of 1. We'll write it down here. The remainder we have got on doing f of 2 by 3 is 1. We'll do the actual division, 3x square plus x minus 1 to validate the result, 3x minus 2. So 3x squared by 3x is x, minus 2 into x is minus 2x. Subtracting means changing the signs. These two will get cancelled out. X plus 2x is 3x minus 1. 3x upon 3x is 1, so we'll let 1. And 3x here. Now minus 2 into 1 is minus 2. Change the signs. 3x minus 3x cancel out, minus 1 plus 2 gives 1 as the remainder, which is same as the one we have got here. In this video, we have seen what's the remainder theorem. The theorem states that for any algebraic expression f of x which has got a degree is represented by n here, greater than or equal to 1. When we divide this with x minus a, where a is any positive number, when we do this, the remainder can be obtained by doing f of a. F of a is nothing but substituting a in place of x in the original equation. We have seen the proof, and we have looked into the usage wherein we try to calculate the remainder using the theorem and also by using the original division process.